Okay, this is the practice test for Chapter 5, and the first question here says, what's the probability that z is between negative 2.01 and 2.01? And so to answer this question, we can just go to the Excel sheet, go to the z and t scores sheet, and it gives you between two z-scores. So just put in your lower z-score here, your upper z-score here, and we'll get 0.955 approximately. And so that would be your answer to the first problem. And actually that turns out to be, let's see here, I believe that's answer B. Next one is between these two z values, and you would go the same place and do that, and your answer is A. The next one is between two t-scores, so to answer that problem we would go to the Excel sheet, and if you scroll down you'll see between two t-scores, here we go, between two t's, and so we put in our lower t, the upper t, and our sample size, which is 16, and we get an answer here of 0.9799, which is about a 98% probability. So 0.98 would be the answer to this problem, which is answer C. On problem 4, it says what score would you need to get on the SAT to be in the upper 5% given the population mean is 500 and a standard deviation of 100? Well, this is a backwards or an inverse z-score problem. You're finding the score given the probability. So to answer this problem, let's move over and move up a little bit on this sheet, and we get a place here where we can find inverse z-scores. So you put in your mean, which is 500, standard deviation is 100, and we want to be in the top 5%, which means that there's only 5% of people to the right, so we put in a 0.05 right here. This is the z-score, and here's the thing we're actually looking for is the person score, and it would need to be a 664.48, so that would be the answer to that problem. Let's go on to the next problem. It says use this information for the next three problems, that the average jumping distance is 6 feet with a standard deviation of 1 foot. And problem 5 says find the probability of randomly selecting a male that can jump 7 feet or more. So on this particular problem we're dealing with just a z-score for a particular person, no sample size or sample mean, and it says greater than that, so we want to put in your x is 7, your mu is 6, your standard deviation of 1, and it says greater than that, so we're looking right here at 0.1587 approximately. On the next problem, it gives you a sample of 49 males between the ages of this, and it says having a sample mean jumping distance, or an x bar, of 7 feet or less. So we're using the same information that your mu is 6 and your standard deviation of is 1, and we have a large sample size, 49. So what we'll do is scroll down here a little bit, and we have our z-score with the x bar in it, and it's the information here was that the x bar was 7, the mean was 6, standard deviation of 1, and the sample size was 49. And let's see here what it was interested in. I think it was interested in the probability that somebody jumps 7 feet or less, so that would be to the left. So your answer to this is 1, or in other words 100%. On the next problem, very similar, it just changes your sample size down to 10, and it says a jumping distance between 5 and 7 feet. Well, since you're dealing with a small sample size and we're interested in the sample mean, x bar, then we'll have to use the t-score. So scrolling down just a little bit, we're in the t-score area, and now between two t-scores we'll have to use this area right here. Our lower is 5, our upper is 7, the mean was 6, standard deviation of 1, and our sample size was 10, so our probability is 0.988, or rounded to the nearest hundredth, 99%. On problem number 8, it's actually a binomial distribution. It's giving you a probability, 4 out of 5 or 80% of dentists recommend Trident gum. What is the probability from a sample of 200, that's your N, that no more than 150 dentists will recommend Trident gum? So your lower number of successes is 0 and your upper is 150. So this is a binomial problem, so you go to your binomial sheet and we put in our N, which is 200. Our lower number of successes is 0 and our upper is 150 because it said no more than 150. That's 150 or less, and our probability of success was 4 out of 5 or 80%. And we get the answer right here of 0.049, and that would be the answer to problem 8. Problem number 9 is very similar. It's another binomial problem. So without looking, with a deck of 52 cards, you guess its suit. There's 4 suits. So after you check, you replace the cards, so the probability remains each time, and you do this 40 times. So our probability, our P, is 0.25 since there's 4 suits, 1 out of 4. Our N is 40 since we're doing this 40 times. And it says what's the probability that we'll have at least 13 correct. So our lower is 13, our upper is 40. So to do this problem, it's binomial again. So we want to get to the binomial sheet as soon as the computer catches up to us here. So the N is 40. We're doing this 40 times. Our lower number of successes is, I believe it says on this problem, let me think here, I think it says at least 13. So at least 13 means 13 or more, clear up to 40. And our probability of success was 1 out of 4 or 0.25. And we get our answer here, which is 0.17913. Last couple problems here. Problem 10 says that the life of a freeze-breeze fan is normally distributed with a mean of 4 years and a standard deviation of 1.2. The manufacturer will replace any freeze-breeze fan that breaks while it's under guarantee. How many years should a freeze-breeze fan be guaranteed if the manufacturer does not want to replace more than 5% of them? Well, this is a inverse z-score problem also. So we'll have to go to the Excel sheet, and we'll need to go back to the Z and T score sheet. And this is an inverse Z-score since we're finding the X, how long it should be guaranteed. So let's go up to that area. And the mean on this freeze-breeze fan, or whatever, if we think back to it, I think our mean was 4 with a standard deviation of, let's see here, what was the standard deviation? I think it was 1.2, and they both were in units of years. And what we need to do is find the score that gives you only 5% to the left. We only want to replace 5%, so we only want to replace the worst 5%. The probability to the left is 0.05. We do that, we get the z-score is negative, and it should be because we don't want to guarantee the middle 50%. We want to guarantee just the bottom 5%, so that your z-score should be negative. And here's how long you should guarantee the fan for 2.026 years. And problem number 11 is the exact same type of thing. The mean on that one is 3.5, and the standard deviation is 0.7, and you want to only replace the bottom 10%. So I believe that's the way the problem works there. Let me try that. I think it was 10%, and so I get 2.6029. And just checking, that's pretty sure that's what problem 11 was. 0.7, no more than 10%. So that would be the answer to problem 11, and that's the practice test.